Hi, welcome to the assignment number 5, problem number 5. The problem is, the task is to design and implement methods of least recently used cache. The class has two methods, get and set, which are defined as follow: get and set. Here, first of all, we discuss what is LRU, least recently used cache. So if we see, cache memory has a limited memory storage. So for example, if this is the bucket of the memory, it can only fit three values. First we put 3, insert, then we insert 6, then we insert 9. If we want to insert the number 12, it has no memory. So what do? Then we use the old used memory. We remove the least used element from here, that is 3. Then we remove, and it will become like it has some space for 12. Then what we do, we move this 6 to here and 9 to from to here. We move them, and then it gets some space here. Here we insert 12. So this is how the least recently used cache method works. It has two methods, get and set. So we are going to implement this problem by using hash map and double linked list. Let's see how it is going to be. First of all, if we take one node in the double linked list has previous and next, and the key and value. So here the key and value is going to be stored in the hash map. If you see, this is the key and this is the value. So here key will become for example, if you see, the first element would be always the previous is called null and next is called also null, and if the entry is supposed to be 3, here it will store 3, and the pointer to this node is going to be some 101. The pointer address of this node is going to store here 101. In this, it has the key and the actual data of the node. It's supposed, let's take 100. So this is the this is how it is going to implement. So if we want to add one more element, for example 6, then it has some value, then it is going to become to the next element of the next node, and the references pointer will become change. That means if it is not 2 memory allocation, then it is going to be the not 2, and the key values become 6 comma something 102. The previous and next are going to be different. That means here the next of the first node is 102, and the previous of the second node is 101. It is going to be like this. So looks like, if we see, this is it, this linked list looks like queue. So in the queue we have the two that is two references, like this is, we call the first element as first, and the rear pointer is there, 2 pointers, first and rear pointers. So now this act as the first pointer, and this act as a front pointer, and this is act as a rear pointer. So if we insert one more, then it will become something 103, then it will become like this. Totally we get like this, 9 comma 103, and this is the actual data of the nodes, and this is the previous ones 102, and the next is going to be null. if we see, okay, so this is the how the data structure is going to be stored in the memory. So if we want to perform the methods get and set operations, first so for the set operation is nothing but inserting this elements into the hash map and linked list, double linked list. That is going to be order of one performance, because we are just inserting elements from here to here, and this is going to be order of one. This is called set method. And what is get method is, in the set method, let's finish the set method first. It's a set method. If we want to insert one more element, something like this, there is so if it is a structure, so there is no space for the one more elements. For example, 18, if you want to insert the 18 element, there is no space. There is no space for the new elements. What do? We have to delete the least recently used one, nothing but 3. So we remove the first element, first node in the double linked list, and then the friend pointer will become here. Then we allocate the new entry here. Now the rare point becomes this one, 18th. So then we get space. So then next, the most recently used one, the least recently used one will become 6, and most recently used one become 18. It's going to be rare pointer now. This is how we perform in the set method. In the get method, let's see, if we want to insert the 6 pointer again, 6 key value, then it's already there. What do? We check each and every hash map. If it is already there, we just take this from and move it to the recently used one. Then it will become, now the front will become this one, and the rear will become the 6 point. So this is how it is implementing the least recently used cache problem. And if we see the code here, first we create the node for double linked list. We are taking key and values, and then previous and next, and we are creating one dictionary here, dictionary int r.node, and we are creating new dictionary, and we are taking head and tail, like mean front and rear pointers. And then we are initiating total items in the cache and maximum capacity of the cache. We are taking variables as them, and we are implementing the LRU Cache method. For implementing the LRU Cache method, we first check the initially we initialize that total number of items in the cache is equal to 0. Then this maximum capacity, we allocate this into here. This is the construction we are initially building, LRU Cache. So here we initially we are head is equal to new, we are taking new node as a, and tail is equal to new, and head dot previous must be the null, and tail dot previous. Initially the first node is always become the head and tails. So the by default first node, next and previous are null. So this is how we are writing the code for this. And the next, for the get method, we are taking for the get method, first what do we check that node is already there, or if not, then if it's not there, we return -1. If it is there, we move that head node to the uh, rare pointer, rare. So that is how we are implementing this get method. In the set method, we're allocating the nodes into the memory. So for that, we check if the node is, if there is a space or not. Items, if the item is not there, then only we push that element into the bucket. So if it is we take the new node, and the key value must be key, and node dot value is equal to key. And dictionary, we use the dictionary first, then we put that basing here we calling recursive method, but by setting we are entering that element into the hash map. And if the item is so if the total items in the cache if it exceeds the memory, then we remove the first element of the first node of the linked list, and then we insert that into the rare pointer. So this is my approach to implement the LRU cache. And here the time complexity is only order of 1, but the space for the space we are taking 2 dictionaries, so it would be order of n. This is my approach. Thank you.